Welcome to Factory Design Pattern, how to make pizzas the right way. All this content is coming from Headfirst Design Patterns book. I took all the examples from their Java examples and put them in some C Sharp. So we're going to be working in C Sharp today. I just wanted to quickly hit what is a design pattern for those of you who are watching that aren't really sure. You've heard the term maybe, but a design pattern is nothing but a general reusable solution to a commonly occurring problem in software design. No matter how long we develop software, we continue to run into the same types of problems that design patterns fix. So it's not a finished design that can be transformed straight into code, but it's rather a description or a template for how to solve a problem that can be used in many different situations. And today we're doing the factory one. I think it was about a year ago we did the observer pattern and the decorator pattern, and those are saved on the drive if you want to look at those two. Those are two good ones as well. If you can't find them, just hit me up and I can share them with you or show you where they're at. But there's also the power of the pattern, besides being able to say, hey, this kind of a problem, and we know how to attack it. There's more power to that than just that. When you communicate using patterns, you're doing more than just using lingo. As a team, shared pattern vocabularies are powerful. We can say a whole lot with saying less, as that second point points out. When you use a pattern in a description, other developers quickly know precisely the design you have in mind. And it puts everybody on the same page. So learning patterns is a really good thing as a team to do. And that's why we're trying to just teach as many different patterns as we can so we can all get on the same page. And it turbocharges your development team. I'm not sure if I shared. I didn't. Let me pull over a page. I like this. So here you got Mel's Diner, if you ever watched Alice. This is two people taking an order. You got Alice, who has this big long description of what she needs, and you have Flo, says, give me a CJ White, black and white, blah, blah, blah. That's the power of a shared vocabulary. That's what we can think about patterns. So you got this guy who's deciding how to fix this problem in code. He says, what I did is make a broadcast class, and it's cool because I have listeners that can join the broadcast and they can come and they can go. And then you have Rick saying, well, why didn't you just tell me you were using the observer pattern? And that's what the power of the shared pattern vocabulary is. So let's get started. I want to introduce our awesome pizza software. We decided to make pizzas. We're really good at it, and so we decided to make software for our pizzas. So our pizzas, we have a pizza class that will add some toppings, prepare, bake, cut, box, and we have an order pizza method where we can just order the pizza and have it do all the things, and then we get pizza. This is just wonderful. We have pizza. That's your basic pizza software. Let you look at it for a second. Looks easy, no big deal. All right. Well, we had a great simple pizza app that made us great cheese pizza. But you know what? We decided that cheese pizza wasn't all we wanted. We wanted two more pizzas. We wanted a pepperoni and a Greek. So we needed to make some adjustments. Like we're going to create more specialized classes than just a pizza class that inherits from our base class pizza. And we're also going to change a little bit how our order pizza works. So let's look at our pizzas real quick. We've got our pizza class, our base pizza class. It still does everything it did. It puts sauce on the crust. But now we're gonna add like a cheese pizza that inherits from pizza, and we're gonna add cheese in the toppings. Greek's gonna do the same thing. Pepperoni's gonna do the same thing. This is awesome. This is a great way to solve it. So, and what we're gonna do with order pizza now is we're just gonna send a string in and tell it what type of pizza we want, and voila, we get the kind of pizza. So if we look at order pizza now, we're sending the pizza type by string, and we can just say, okay, cheese, Greek, pepperoni, awesome. So we talked about this a year ago about the areas of your code that change. This is what you're looking for in good object-oriented oriented design, what's the area of your code that changes the most? You want to pop that out. That's your problem area, and that's the stuff that will force you to crack open your code over and over again and have to modify it. So this is the stuff we want to pull out. Yeah, identify the aspects of your application that vary and separate them from what stays the same. That's called encapsulation, right? We're encapsulating our code for things that change so that we don't have to make a change in other different places or in something larger that could cause bigger problems. So yeah, we got ourselves a really cool little solution to adding more pizzas. We've added 2 more pizzas. We're just doing a switch statement. But wait, we just got news. This just in. Next month, in a few weeks, we want to add clam pizza and veggie pizza as well. So at this point, we know we're going to have to come back in here and we're going to have to modify this code again. Now that breaks the open close principle of solid. Solid is the single responsibility principle, the open close principle, the Liskov principle, the interface segregation principle, and D is the dependency inversion principle. We break O every time we got to come in and make modifications. Your classes need to be built in such a way that they're open for extension but closed for modification. So let's see how we're gonna fix this. All right, so let's take out the creation part of order pizza, since that is the part giving us problems. Plus, we may have other clients that want to order pizzas and or get pizza information, like a menu client. So we're going to make a pizza store class. In our store, we also decide to pull out the newing up of pizzas. Whenever you see the keyword new, that could signal. A lot of times signals a problem. It makes it when you're newing up objects, you're now coupled with that object. If that object changes, you have to make a change. If the argument signature changes, you have to come in and change stuff that news it up. So whenever you're seeing new a lot, this is a code smell that there could be something up. And so we're going to pull that out of our pizzas, or pull the newing out of pizzas from our order pizza class, and we're going to move it into a new class that we call a factory. That factory will be in charge of giving us the pizza that we want. It's a simple pizza factory. Let's check this out. All right, so all we do in the simple pizza factory is we're going to send in the string type like we did before. We're going to look through the string types, and we're going to send back the proper newed up concrete object. So you might ask yourself, what's the advantage of this? It looks like we're just pushing the problem off to a different object or class. And that is true. But one thing to remember is that this simple pizza factory may have many clients. So we've only seen order pizza from our main menu so far. However, there may be a pizza shop menu class that uses the factory to get the current description and price. We might actually have a home delivery class that handles pizza in a different way than our pizza shop class does. That's also a client. So by encapsulating the creation logic into a single class, we now only have one place to make modification when changes are needed. So when we add new pizzas, or let's say that clam pizza needs a new argument, we're not changing 8 different clients to solve this issue. Check out pizzas. I just made more pizzas, I think, down here. No changes there. All right, so we need to change our code and let our factory handle things. We'll also add the factory and use it in our order pizza method, which is now in our new pizza store. Let's check out the pizza store. We have a store now. We're gonna remove it out of this main menu. That doesn't make a lot of sense, especially since things can be changing all the time. And in our store, we're going to hand the store the pizza factory, right? So the store and the factory in regular retail or business is never the same thing. You'll have a storefront, and then you'll have a factory that makes the thing that the storefront sells. So that's basically all we did here. We're going to pass our factory into our store and say, this is the store that you're going to use. And we're moving order pizza into this away from the main menu, but we're letting the factory decide. We're calling the create pizza factory method, and this is what gives us our pizzas. And also notice no more new keywords, no more concrete instantiations. We've now decoupled the pizza store from the concrete pizzas. All right, so up here in our code, we're going to instantiate a simple factory. We're going to make a store and pass that factory to the store. And then we're going to order some pizza. Let's watch this work really quick. It's pretty simple, but it's still kind of interesting. So the pizza store is going to be we're calling Order Pizza, but then inside Order Pizza, it's going to call the factories Create Pizza, and Create Pizza gives us our cheese pizza. But now we just went to cheese pizza. I skipped ahead. Sorry. The cheese pizza is inheriting from pizza, so it's going to grab the basic stuff that pizza gives it, which is sauce. And now the cheese pizza is going to add its own sauce. I don't know why I added sauce there. That's double sauce for the cheese pizza. Very good. And it's going to add cheese. Should have added 2 cheeses. And now we're ready to return the pizza that the pizza factory returned. It's a cheese pizza. It's got 3 toppings: sauce, more sauce, and cheese. And now now that we're back in pizza, because we're calling prepare, we're calling bake, we're calling cut. I don't need to I don't need to go into these. And Order Pizza is now going to return the pizza to the customer. Now we have a cheese pizza, and then we'll do the same thing with the Greek. You don't need to see that, except you can see that the toppings now have 5 toppings: sauce, cheese, spinach, fat mozzarella, and tomatoes. And we'll just write that up. We got a cheese pizza and a Greek pizza. That's cool. Oh, sorry. All right, so this is the simple factory. It's not really a design pattern yet, but it does provide advantages such as single points of modification for many clients, and allowing those clients to not be coupled with concrete instances. But we can do better.